You're watching the third lesson on squaring numbers and square roots. In this lesson, we're going to talk about finding the square roots of numbers that aren't perfect squares, or at least estimating them. So, what does it mean to find a square root? So this is going to be a bit of review. To find a square root means to find a number that, when multiplied by itself, gives you the original number. So for example, if we do the symbol, that's the symbol for square root, and we draw a 9. So what this question is saying what number times itself gives you 9, right? So we should know that 3 times itself gives you 9 because 3 times 3 gives you 9. So that's what finding the square root means. So finding the square root is when you are given a number and you need to look for the number when multiplied by itself gives you that first number. So the square root of 16. What number multiplied by itself gives you 16? Well, 4. We can also rewrite this as 4 times 4 equals 16, or 4 squared, because that's the same thing. If you remember from our previous lesson on square roots, that little 2 tells you how many of this number you have. So this little 2 tells me I have 2 of these 4s, and I multiply them through. So it's relatively easy to find the square roots of perfect squares. But what if you don't have a perfect square? So in this case, we have square root of 36 and the square root of 30. So the square root of 36, everyone should know what number times itself gives you 36, right? Well, 36 is a perfect square. We know this because if we were to draw a square and we say the area is 36, and this is a square, so these sides have to be equal even though they don't look like it. What is the length of this side? Well, 6. Well, for this to actually be a functioning square, the other side also needs to be 6, otherwise it becomes a rectangle. So we know that the square root of 36 is 6, right? Because 6 times 6 is 36. But what about the square root of 30? So if I try to draw a square with an area of 30, well, we'd quickly realize that there's no number we could multiply by itself to get 30, right? 30 is not a perfect square, so we can't find the answer. We could have a length of 10 and 3, but these aren't the same number, so not a perfect square, it's a rectangle, right? We could have 5 and 6. Yeah, these numbers are close together in value, but they're not the same number. So they're not a perfect square. You'd end up with a rectangle. You need the number to be the same for it to be a perfect square. You need to be able to multiply a number by itself to be a perfect square, to get a perfect square. 3 times 3 is 9. 2 times 2 is 4. 5 times 5 is 25. Each of those numbers can be made by multiplying a number by itself, right? 5 times 5 is 25, right? That means 25 is a perfect square because you can multiply a number by itself. 2 times 2 is a perfect square. It creates a perfect square because 4 is the result of 2 multiplied by itself. And the same is 36 because 6 times 6 gives me 36. And so we know 36 is a perfect square because 6 times itself gives me 36. So when you don't have a perfect square and you have to find the square root, you need to estimate. You need to estimate. Now, some of you may think estimation means guess. It doesn't mean guess, it means an educated guess, meaning you try and get as close as you can. You don't just say, oh, it's 4, or 3, or 2. You don't just guess at it. You try and figure out what number would be the closest to getting the perfect square. So in my example here, we have a square with an area of 7. Well, what is the side length of this square? Well, I can't use whole numbers, right? There is no number no whole numbers other than 7 and 1 that multiply into 7. And this wouldn't make a square because the sides aren't the same. So we know that we can't use whole numbers. We have to find numbers that are in between them, Or, in other words, we have to find the decimal. So, what is the side length of a square? Well, we know the area of a square is side length by side length. And for any shape to be a square, it must be the same number for both sides. So we're looking for the square root of 7. Is 7 a perfect square? No, because no number multiplied by itself gives me 7. So to estimate, we need to pick the closest perfect square, bigger and smaller than 7, right? So because 7 is not a perfect square, we need to find the closest perfect squares to 7. One bigger than 7 and one smaller than 7. So I like to draw a number line, right? I'm looking for the closest perfect square smaller than 7 and the largest perfect square, also a larger perfect square that's close to 7 as well. Well, the two closest perfect squares, one that's lower is 4 and one that's higher is 9, right? We know that the square root of 4 is 2, and we know the square root of 9 is 3, right? So we write the square roots here, and we write the answers below. So now we know our answer should be between 2 and 3, right? Perfect. So we now have a number line, and we know, it should be between 2 and 3, and we got to get a decimal. Now, a lot of people will stop here and go, oh, it's between 2 and 3, so that's 2.5, right? Sorry, it should be 2.5. Right? And that's not always the case. That's not going to be true all the time. And we're going to take a look at this number and see if it is. Right? Using the number line, we solve each square root. 4, square root of 4 is 2, square root of 9 is 3, and we have 7. The square root of 7 in between. So we know that the square root must be between 2 and 3. Well, we can't just say 2.5 because it's not exactly in the middle. 7 is not equally distant from 4 as it is to 9. Right? If I went 4, 5, 6, 7, I moved up 3 numbers to get to 7. But if I'm going from 9 to 7, I'm going 9, 8, 7. So I had to move 3 numbers to get to 7, while 9 going backwards, I only had to go 2 numbers backwards, right? So is it closer to the 4 or is it closer to the 9? Which one took the lowest amount of steps? Well, because it's closer to 9, we know it has to be more than halfway, right? If it was both equal, 3 and 3, then you know it's halfway. But because it's closer to 9, it must be further along the number line. So we can't say 2.5, right? It's a little bit closer. So I'm going to say 2.6. I'm going to say 2.6 because it's a little bit closer to the 9. Maybe even 2.7. Okay. Well, 7 is closer to 9 than it is to 4, right? So the number line should look more like this. So that 9, 8, 7, but this is 4, 5, 6, 7. It's closer to the 9, which means if I'm going this way, it should be past 2.5, which is in the middle. It's closer to 9, so it has to be higher than 2.5. It's more than halfway. So I would estimate the answer to be around 2.7. Well, we can use a calculator to check our answer, right? I can check my answer by using a calculator. Well, I pull out a calculator, and I go, hopefully I find the square root. There it is. So if I go, okay, what's the square root of 7? 2.645. So I got the answer, sorry, got 2.61 here, it says 2.64. Either way, you end up with 2.6. Let's go with 2.6. Well, I said 2.7, so I'm pretty close. I'm pretty close. However, when we do these questions on a test or an assignment, you need to estimate your answer using a number line. I don't want you just using a calculator because anyone can punch these numbers in. I want you to show me you understand how the calculator gets those answers or how we can estimate the square root of a number. So using these, I want you to try on your own, pause the video and try on your own to estimate these numbers. All right, so hopefully you paused and solved them. We're going to do the first one. So we have the square root of 12. We know 12 is not a perfect square because no number times itself gives me 12. 4 times 4 doesn't give me 12. 3 times 3 doesn't give me 12. Okay, so then I'm going to draw a number line. And I'm going to say, well, this is the square root of 12. Right? That's what we're looking for. Okay, what is a square root or a perfect square that is smaller than 12? Well, 9 is a perfect square, so 9 is the square root I'm looking for that's below 12. And what's the next perfect square larger than 12? Well, 16, right? 16 is the next largest perfect square. So we know if we find the answers to this, square root of 9 is 3, and the square root of 16 is 4. So now we know that the square root of 12 is in between 3 and 4. Okay, well, which is it closer to? Is it closer to 9 or is it closer to 16? Well, let's start here. 9, 10, 11, 12. It's 3 steps away. Okay, 16, 15, 14, 13, 12. So it's 4 steps away from 16, but 3 steps away from 9, meaning that it's probably closer to the 3 side. It's probably closer to here. So it's not going to be 3.5. It's probably going to be I'm going to say 3.3. I'm going to say 3.3. Okay, so let's check our answer. What is this square root of 12? 3.46. So just below 3.5, 3.46. And if you were to round, you would say 3.5, but I was pretty close. I was 0.1 off, 0.01 off, 0.1 off, yeah. So estimating doesn't mean getting the right answer right away. Estimating means gets close to the right answer. I don't want people to just go, oh, it's 3.2, right? You should be within 0.1 or 0.12 of the answer. You should be able to get within 0.12 of the answer. So I was a little bit off on this one, but we can try another one. So we have 21, and as long as you show me the number line, as long as you show me that you know how to estimate them, then you should be fine. So we're looking for the square root of 21. Okay, well, the next smallest one is, again, square root of 16, right? And the next largest one is square root of 25, right? We're 16 and 25, which means it's between 4 and 5. And so we're trying to see, okay, well, is it in between, is it closer to 16 or is it closer to 25? So we go 16, 17, 18, 19, 20, 21. Okay, so it's 5 steps. But this one is 25, 24, 23, 22, 21. So it's closer to the 25. So I'm going to say about 4.6. I want to say 4.6. Okay, what's the square root of 21? So around 4.58, right? So pretty close. I was 0.02 off from our answer. And so this is how you estimate square roots of non-perfect squares. You find the smallest square, perfect square, that's closest to the number you're looking for, and the next largest perfect square that's closest to the number you're looking for. And then you find out, well, what number is that square root between? And from there, you can figure out where it would be. So if you are looking for a number that has a square root between 2 whole numbers, for example, what whole number has a square root between 6 and 7? Then you create a number line, right? So in this case, I'm asking a question that's the reverse of this one. Here I'm giving you a number, and I'm saying it's not a perfect square. I'm saying it's not a perfect square. So we got to estimate it. In this one, I'm giving you 2 numbers, right? I'm giving you 2 numbers, right? And I'm saying the square root, right? what whole number has a square root between 6 and 7? So what number on a number line would be between 6 and 7? So what is in between the square root of 36? And what is the square root of, in between the square root of 49, right? Because 7 times 7 is 49, 6 times 6 is 36. It keeps doing that, sorry. And here we have our mystery square root. So we draw a number line again. This is saying we have the square root of 6, not the square root of 6, but we have a number that has the square root of 6, and a number that has the square root of 7. So you go backwards, right? What number times itself, or what number do we get if we times 6 by itself? 36. That's the perfect square. What number times itself gives us the perfect square of 7? 49, right? So the square root of 49 is 7, the square root of 36 is 6. What number is in between this? Well, what whole number has a square root between 6 and 7? So we're looking at what number has a square root of 6. Sorry, my voice is going. What whole number has a square root of 36, and what whole number has a square root of 7? And we just solved that. 36 and 49, right? So we know our answer, this mystery number, can be in between 37 and 48. It can't be 36 because we know this, and it can't be 49 because we know that. So it has to be between 37 and 48. So we have now found a range of numbers that this mystery number could be, right? So in this question, it's asking us what whole number has a square root between 6 and 7. It's not just one number, it's a range of numbers, because the square root of 37 would be really close to 6, but just a little bit bigger. And as we go up through these numbers, we now know that the range of numbers that would have a square root between 6 and 7 is 37 to 48, right? The square root of 36 is 6, the square root of 49 is 7, and we're trying to find what number have square roots between 6 and 7. All right, so find the numbers whose square roots are between 4 and 5. So again, pause the video, see if you can solve it. Okay, so I'm going to do one of them with you. All right, so we have this, what numbers whose square roots are between 4 and 5? So this question is saying we have a number whose square root is 4. We have a number that square root is 5. And we're trying to find the range of numbers that would have a square root in between 4 and 5. So what number gives us what number, if we square root it, gives us 4? Well, 4 times 4 is 16. And what number, if we square root it, gives us 5? Well, we know it's 25. Right? Square root of 25 is 5. The square root of 16 is 4. So any number between 17 and 24 would give us any number between 17 and 24. If we found the square root of any number in between here, would give us a square root between 4 and 5. We can check that, right? 17 square root 4.1, right? 18 square root 4.2. So we know that any number between 17 and 24, if we square root it, we would get a value that's in between 4 and 5. So try these questions out. The challenge question is number 21, and I'll see you next lesson.